Thank you for my introduction. Well, friends, good morning all. My topic of presentation for today is recent advances in machine learning. Well, I'll be concentrating on, in this session, I'll be concentrating on giving basic definition of machine learning, some of the basic applications of machine learning, some of the potential applications of machine learning, and then I'll switch on to, some of the drawbacks or limitations of machine learning. And I'll be focusing on two of the major limitations of machine learning, and then we'll be discussing on how we can solve them using some of the recent advancements in machine learning. Well, to begin with, let us start with uh, the definition of machine learning. So what is machine learning? So as we all know, learning, we humans learn by observing the things around us, by getting the inputs from our friends, relatives, or our parents, and observing from our peers. And also, we'll be learning from our own experiences, isn't it? In the same way, machine learning deals with making the computers learn, understand things, and make decisions on their own. That is what is machine learning all about. We humans don't depend on anyone, right? We'll be making our own decisions. We try to understand the things and then we try to come up with a solution given a problem. Yeah, that's what we'll be training the machines to do in machine learning. Yeah. So machine learning is a field of study that gives computers the capability to learn without being explicitly programmed. See, in earlier days, if we wanted a computer to do something, we had to write a program. If you want the computer to find factorial of a number, yeah, we have to write a program and instruct it what to do and how to do. Right? So I mean, computers dependent on were used to computer used to be dependent on the humans. They didn't had that intelligence, right? They couldn't act on their own. But with the advancements in AI and machine learning, we can make the computers to learn by themselves and to act or make decisions without interpretation or involvement of others. So that is what is machine learning. So machine learning is actively being used today, perhaps in many more places than one would expect. Well, where exactly is machine learning used? What are the areas of applications of machine learning? Well, to be frank, wherever, whichever domain generates some digital data, whichever domain has some data, machine learning can be applied on that. Because machine learning, you know, uh, tries to understand the patterns from the data and construct some kind of hypothesis and then come up with some kind of decisions. So wherever data is there, you can apply machine learning. So some of the major applications of machine learning include image recognition or image classification, you can call that, speech recognition, traffic prediction, and then product recommendations, as you might have seen in Amazon, right? And then self-driving cars, obviously, even in India, some of the cars today have ADAS. You might be knowing that. So that is level 1 of autonomous driving. And then email spam and malware filtering, intrusion detection, privacy, security, whatnot, banking sector, insurance sector, production sector, design. Take any sector that has some data available, right? Machine learning can be applied to understand the patterns and to predict something. Well, let us not dig deep into the techniques of machine learning. Our focus is on some of the recent advancements of machine learning. So, well, what are the limitations of machine learning? Machine learning algorithms require massive amounts of training data. So you have to train a machine learning algorithm using some data, right? Normally, to understand the data, and to come up with some kind of patterns from the data, machine learning algorithms require huge amount of data. If the number of data is less, there is always a chance of overfitting, right? And then When you talk about, continuous data, see, normally supervised learning. In supervised learning, what will happen? You will have independent variables and you will be having a class label. So class label, that is, you have to do the labeling explicitly, and you have to provide the data, labeled data to the machine learning algorithm. But generating of the labels in real-time applications, right? That is a tedious task. It is very difficult to generate the labels as and when the data is generated, right? And then there is a chance that there is a bias in the data, unbalanced data. You might have heard about this term, where say 90% of the data belongs to a particular category. Only 10% may belong to a particular category. So machine learning algorithm will obviously be biased to the majority of the data, right? And then privacy preservation. Well, what happens in a traditional machine learning algorithm? Say, for example, consider Facebook. So almost each of us is using Facebook from our mobile devices, right? Or you can be using from laptop or other devices. So when you are using Facebook, what will happen? All the data, including your personal data, like your location, right? Uh, all the data which is not to be exposed, right? All the data will be transferred to the central cloud of Facebook, so that the Facebook can run some kind of machine learning algorithms on the data that is obtained from the users. So your data is being exposed, right? Not only Facebook, any digital platform, right? They collect the data and they strive on the data that is collected from the users, so that they can try to understand the patterns of, the user behavior, patterns of their browsing, so that they can come up with some kind of predictions that will be helpful for promoting their products. But in the process, your data, which is private to you, is being exposed, right? It is not supposed to be exposed, right? But even though there are many privacy laws, right? But still, users' private information is being exposed and sold out to the to some, yeah, organizations, right? Even recently, you might have seen many users' data is exposed from Twitter through Facebook. Yeah. So preserving the privacy is one of the major challenge in machine learning. Why this issues comes? Because the data from the local devices has to be transferred to the central location or to the nearby edge devices for training the machine learning algorithm, right? That is one of the major challenge in or limitations of machine learning. Another important, limitation of machine learning is, see, for example, as humans, if we take some decisions, right? When someone asks you why you have taken this decision, you should always justify, right? You can always justify or explain your decision. What prompted you to take that decision? You can explain. Humans can explain or justify their actions or their decisions. But what about machines? See, in machine learning algorithms, what will happen? You'll be providing some data. The machine learning algorithm will learn from the data and it will be giving some kind of predictions. How those predictions are given, nobody knows. What is the reason that a particular thing is classified as cat? Nobody knows. What is the justification behind the decision? Nobody knows, because of the black box nature of the machine learning algorithms. So they strive on the data, they take you have to give some data as input to it, and then they will try to understand the patterns from the data. First, that's it. They'll be giving the decision. But what is the basis of this definition? What is the explainability, the justification, right? That cannot be done by machine learning algorithms, isn't it? So these are some of the limitations of the machine learning algorithm. Well, in today's session, I thought of covering how, the privacy preservation and explainability aspects of machine learning can be, worked on. Well, now, uh, federated learning. Some of you might have heard about this term. Recently, many of the researchers around the globe are working on federated learning. It addresses this privacy issue. Privacy preservation issue can be addressed by federated learning. Well, what is federated learning? See, in a traditional machine learning process, what will happen is all the data will be transferred from the local devices to the central cloud, isn't it? So thereby exposing the private information of the users. But that is, I mean, to put it simply, the data will be transferred to the location where the machine learning algorithm is supposed to be trained, or data has to be transferred to the computation where the computation happens. Data has to be uploaded to the location where computation has to happen. But in federated learning, instead of transferring the data from the local devices to the central cloud for machine learning training, what will happen is the global machine learning algorithm itself will be offloaded or transferred to the individual devices. Right? Itself will be transferred to the individual devices. 1 second. Well, sorry for the disturbance. So can you see my screen?
Sir, yes, sir.
Is my screen visible? Yeah,
Yes, sir.
fine. So where are we? So in federated learning, instead of transferring the data to the cloud for the training process, the model, the machine learning model itself will be uploaded to the individual devices or the edge devices where the data is, I mean, being generated. That is, the computation will be offloaded to the source of the data. So what will happen then is, in the local devices, the machine learning algorithm will be executed and only the model parameters, right, will be transferred from the local devices to the global machine learning algorithm. So what is the advantage of it? So by using this federated learning model, you need not transfer the data from the local devices. All the data that is not relevant, that is not required for training the machine learning algorithm. Your private data need not be transferred. Only the parameters which are required to train the global machine learning algorithm, right? Only the local updates will be transferred frequently from the local devices to the global machine learning algorithm. So in that way, federated learning has a huge potential in preserving the privacy of the individual devices. Well, so that is what is federated learning. So federated learning enables mobile phones or local devices to collaboratively learn a shared prediction model. Shared prediction model in the sense the global model will be shared across the local devices, isn't it? So they will be collaboratively working upon the global model, right? While keeping all the training data on the device. So the important point here is the training data will be kept in the individual devices. They need not be transferred to the central location. So decoupling the ability to do machine learning from the need to store the data in the cloud. So that is what happens in federated learning. So this has a huge potential to solve the privacy preservation issue in the conventional machine learning algorithms. So this goes beyond the use of local models that make predictions on mobile devices by bringing the model training to the device as well. Yeah, so this is the advantage of federated learning. So how does it work? So to give a snippet of how it works. So your devices download the local device. It can be mobile or it can be my laptop, any device, any local device downloads the current model, right? The current model will be downloaded. That is the global model will be downloaded and then improves it by learning from the data on your phone. So the model will be trained from the or by using the data that is available on your phone and then summarizes the changes as a small focused update. Only this update, only the update of the model, right, of the local model is sent to the cloud. And again, that is sent by using encryption, where it is immediately averaged with other phones or other user updates to improve the shared model. See, you are not the only client, right? There might be other users. So for example, Facebook. So Facebook wants to learn what are the interests of a particular group of people. So what will happen is the model, the global model will be sent across to the individual mobile phones. The machine learning algorithm will be trained on the data, and then the local updates will be sent from different individual devices to the central cloud. The data will be averaged, right? So that, the global machine learning, the global model will be getting the updates using the aggregation method. So all the training data remains on your device and then no private data is sent across to the cloud. So in this way, your private data is with you. It will not be transferred to the other locations. So yeah, this is how federated learning algorithm works. So as you can see, you will be having a global model, right? That will be, offloading the offloading the training model across to the individual devices. And then the machine learning algorithm will be trained using the local data. The local updates will be sent across to the cloud for global training. Fine. Using some averaging technique. We'll see what it is. Well, coming to different types of federated learning, you can say that, there are three types of federated learning. One is horizontal federated learning, the other one is vertical federated learning, and then you have federated transfer learning. Well, what is horizontal federated learning? So horizontal federated learning uses datasets with the same feature space across all the devices. So that means that all the local devices will have same set of features. The same data, right? The machine learning algorithm will be trained on the same set of attributes across all the individual or local devices. Well, coming to vertical federated learning. So what happens in vertical federated learning? It is different from horizontal federated learning. In vertical federated learning, each device will be having different data sets using different feature spaces to jointly train a global model. So that is what is vertical federated learning. So in horizontal federated learning, each device will be having exactly same kind of features. In vertical federated learning, they need not be having same kind of features. So as an example, consider that there is a client A, right? Okay, say Amazon has information about customers' movie purchases on Amazon. Client A has information or the data related to customers' movie purchases on, say, Amazon Prime. And client B has information about customers' movie reviews from IMDb. Right? Using two, see, if you see here, client A has one data set, client B has different data set. Now, federated learning algorithm will be executed on client A as well as client B. Now, using these two sets of data sets from different domains allows one to serve the customers better using movie reviews information to provide better movie recommendation to the customers browsing movies in Amazon. So from client B, you can learn the movie recommendations, right? The machine learning algorithm can give better recommendations about the movies. So it will learn the recommendations from client B and that information can be passed on to client A. So in that way, the data from client B can be used to give some kind of recommendations to client A. So they can work in collaboration. That is possible through vertical federated learning. And then the third kind of important federated learning is federated transfer learning. So again, it is a kind of vertical federated learning. Well, I guess you know what is transfer learning. So a model which is successful on one data set can be the same model can be used in other applications, right? So even in federated transfer learning, what happens is a vertical federated learning model which comes up with a pre-trained model that is trained on a similar data set will be used for to solve this particular problem. Okay. So how federated learning works? So federated learning revolves around the federated average algorithm known as FED-AVG. It stands for federated average. So Fed average is very first federated learning algorithm formulated by Google, right? Where it has proposed federated learning architecture in 2018 as a white paper. Since then, many variants of Fed average algorithms such as Fed prox, Fed mark, Fed out have been developed. So what is this Fed average? So what happens is, you'll be having lot of individual devices where the machine learning algorithm will be transferred or will be offloaded, right? From each device, you'll be getting the model updates, isn't it? So all the model updates from the individual devices will be averaged and sent it to the cloud for permanent storage. This averaging or aggregation of the model updates from different devices is carried out by federated Fed average aggregation algorithm. It is one of the kind of aggregation algorithm. So at every round, Fed average, the main aim of Fed average is to minimize the objective of the global model, which is the sum of weighted average of the local devices, as you can see here. Well, what are the advantages of federated learning? As we have seen, some of the privacy preservation can be maintained, right? Privacy of a user can be protected. Reduced latency. See, in traditional machine learning algorithm, see, you may have to wait till the data from all the devices is aggregated and stored to the central cloud so that the machine learning algorithm can start being trained. But here it is not required. It need not be the case because as soon as the local device generates some kind of data, as soon as enough data is generated, you can apply federated learning algorithm. So latency will be reduced and then reduced communication cost. See, lot of resources are required to transfer the data from local devices to the central cloud. That need not be the case here because the model will be transferred to the individual devices for training. Since the entire data need not be transferred from the local devices to the central cloud, communication cost can be reduced. And then real-time continual learning can happen. So as and when some kind of new information is available, the machine learning algorithm can be executed at the local devices without bothering the other devices, right? So continual learning can be achieved in real time. And then personalized recommendations. Since the machine learning algorithm will be executed on individual devices, it, it can provide personalized recommendations. Okay. Well, we have seen what is federated learning. What are the potential applications of federated learning? And then we'll see some of the challenges in federated learning. See, every technology has its limitations. The same thing for federated learning as well. Some of the challenges or limitations of federated learning are as follows. So trade-off between noise and accuracy. Well, using differential privacy, we can add noise to enhance the privacy protection. See, in order to provide privacy, we can add some noise to the individual devices. That is what happens in differential privacy. So that, the local data can be diluted, right? So that, there is a less chance of giving up the private information of the users. However, with differential privacy, the performance of the model will be reduced. Why? Because some unnecessary information is dumped into the local devices. Yeah, to achieve privacy. But what happens in turn? Since the data is not relevant, the performance of the model can be reduced. So a right amount of balance has to be maintained between infusing the noise into the data set, and also accuracy is also important, right? So that is one case. And then system and statistical heterogeneity. Well, as you know, each device is heterogeneous, will have their own features, right? They may be using different OS, they may be using different kinds of, you know, browsers, whatnot. They are heterogeneous. In federated learning, there is every chance that, the training will be done on heterogeneous data sets. So training on heterogeneous data set is a challenge. So it is important to ensure federated learning scale effectively to all the devices, regardless of different types of devices. So in federated learning, it is always a challenge to train the model on different types of devices, right? So the dissimilarity of statistical information that is generated from different devices, right, refers to the incapability of one devices to derive the global statistical pattern. So this is the challenge that has to be addressed. The next challenge is communication bottlenecks. See the communication, frequently model updates have to be sent from local devices to the global devices or global or central cloud, right? So frequently we have to send the updates. So some kind of communication cost is incurred here, isn't it? So to reduce the bandwidth utilization, that is also one of the major challenge in federated learning. Then comes the next challenge, poisoning attacks. See what happens in federated learning is the training will be happening on the local devices, right? And only the model updates will be sent from the local devices to the central cloud. But even though only the local updates are sent, the eavesdroppers or the attackers may still analyze the local updates, right, during the transit, and they can construct the data. They can do reverse engineering. From the updates, they can try to analyze the patterns of the data. They can try to extract the private information. Even though federated learning, the main objective of federated learning is to ensure privacy preservation. Through poisoning attacks, there is a chance that, the attackers can get hold of private information. There are two kinds of poisoning attacks, data poisoning and model poisoning. So during a federated training process, multiple clients can participate by contributing their on-device training data. And it is difficult to detect or prevent malicious clients from seducing or sending malicious or fake data to poison the training, which in turn poisons the model. So what can happen is, during the process, uh, the data will be trained on the local devices, right? In data poisoning, the data will be poisoned. The data in the local devices will be poisoned so that, what happens is the attackers can send some kind of fake data, the data which is not present in the local devices, so that the machine learning algorithm can be contaminated, can be biased, can become biased. Model poisoning. So what happens here? Contrary to data poisoning, malicious clients modify the received model by tampering its gradient or parameters before sending back to the central cloud for aggregation. As a result, the global model can be severely poisoned with invalid gradients during the aggregation process. See, every machine learning algorithm will be having some kind of parameters or gradients, right? So if these parameters are poisoned or altered, and before sending across to the central cloud, right, they can impact the performance of the machine learning algorithm. So these are some of the challenges of federated learning. The next important challenge is trade-off between efficiency and privacy. See, in order to achieve privacy preservation, right, and also to secure the data, every time the data has to be some differential privacy is has to be used, right? That will reduce the performance of the model that we have seen already. And also some kind of encryption, the data before the model parameters before send the local devices to the central cloud, they have to be encrypted. The encryption process will again impact the communication, right? It will burden the communication process, right? It will add to the complexity of the communication. So you have to be careful about, maintaining the balance between the to what level privacy and security are required, and also the performance of that federated learning algorithm. That also is important. So that is also one of the major challenges or open challenge in federated learning. Well, this is what is this is about federated learning. Then comes the next important development of machine learning, explainable AI. So we have seen that, one of the major drawbacks of traditional machine learning algorithms is they cannot explain themselves. Why a particular decision is made, that cannot be explained, right? Well, in order to, solve that, you can use explainable AI. What is explainable AI? Explainable AI can explain its decision. To put it simply, explainable AI, right? Using explainable AI, you can, or the algorithms, machine learning algorithms can explain their decisions. So yeah, AI has the power to automate decisions, and those decisions having business impacts, both positively and negatively. But, the reason why AI now is not being trusted is you will be giving some kind of inputs, and input data will be given to the machine learning algorithm, some kind of training will happen, and it will come up with some kind of predictions. Why that prediction is made, nobody knows. So lack of explainability is one of the major factors that is hindering the acceptability of machine learning algorithms. So what is explainable AI? So it is a recent development of AI in which the results of the solution can be understood by the humans. That is, the, the machine learning algorithms can make the results interpretable by the humans, right? So that the explainability part of the AI can be covered. So why XAI? Why explainable AI is required? See, nowadays, from shopping to autonomous driving, AI is used heavily. AI is used heavily, but you know why a particular product is recommended to us? You never know. Some product is recommended to you, but you don't know the reason why that particular product is recommended. So there is a huge chance that you may ignore that recommendation. But with explainable AI, why a particular product is recommended to you, that can be explained. That explainability part can be understood by the humans, so that the humans can understand why a particular product is recommended by AI algorithm, and they can make better decisions, right? So it has become vital to understand the decision mechanism with a comprehensive explanation function. So for instance, a pedestrian was struck and killed by a self-driving car operated by Uber in Tempe, Arizona in 2018. It happened actually. Considering this case as a deep understanding of decision making rationale of the system needed to ensure accountability and trustworthiness. So who is accountable now? See, autonomous vehicles, they make their own decisions. If it is a human driver, you can catch the driver who has done the accident and you can question him and you can detain him and all the legal uh, things can be prosecuted, right? He can be prosecuted legally as well. But whereas in case of autonomous driving, right, who is responsible? What action you can take on the car, driverless car? So it the fault of the manufacturer, or is it the fault of the developer who has you know developed this AI algorithm? Whose fault is this? So there are some ethical concerns, there are some legal concerns, and also some kind of explanation is required from AI algorithms that is lacking in traditional or conventional machine learning algorithms. So there comes the explainable AI part. So what happens is, AI model will be trained on the data. Some other information, if at all, can be added along with the predictions of the machine learning algorithm. Then humans can make better decisions, right? This is where XI part comes into picture. So that is what is explained here, right? So humans will have a better understanding of the decisions that are given by the machine learning algorithms with the help of XAI. So now what is XAI? Well, to put it simply, it is an AI system which explains how decision making, what is the reason behind the decision, what is the rationale behind the decision making process. And that can be explained in simple human understandable form, right? With the help of explainable AI. That is XAI. I guess it makes sense, right? So XAI, basically what it does is, using XAI, the decisions of the machine learning algorithms can be justified or explainable, or they can be interpretable, so that the humans can better understand the decision making process and they can make better decision based on the predictions given by AI algorithms. So, well, this is the first part of this figure. If you see, that is the conventional machine learning algorithm. So there will be a training data, some kind of machine learning algorithm will be executed or trained upon the training data, and some kind of decision will be recommended. But the user has no way to understand why it did that. Why not something else? What is the chances of you know uh, success? What is the chance? What are the chances of success of that particular recommendation? When do they fail? You never know. How can you trust it? You never know. If at all there is an error, how to correct that error? That is very tedious task for the user. But there comes the explainable AI part. There comes the XAI part. Again, the process remains the same. The algorithms will be trained by the training data, and then explainable model will be generated. And then you'll be having an explanation interface. So by using XAI process, the users can understand why a particular decision has been made. Why not? Why not something else? When this model will be successful, when the model may fail, and then they can trust the AI model because some kind of justification is given. And then when or what kind of error happens, that also they can understand so that they can correct the AI algorithm. So these are the advantages of XAI. So again, some different kinds of the same thing interpreting with different interpretation. So for the end users, XAI will explain how decisions have been made and thereby help to audit the systems for any inconsistencies or bias to remove them. Right? Well, what are the challenges of XAI? See, as discussed earlier, every technology has its own challenges or drawbacks. What are the challenges of explainable AI? Number one, lack of expertise. See, most of the persons still lack the expertise to understand the explanation. See, even though the machine XAI algorithms, give some kind of justification, still there are the skilled persons. They may not even understand what is that explanation. The explainability part may not be understood because lack of expertise. And then constant explanations. Sorry, contested explanation. Experts explaining algorithms also make biased and inherently disputed choices. Dynamics of data and decisions. Data and decisions change over time. Therefore, explanations also change. See, the explanations will not be constant. Explanations again will be dependent on the data that is available. So the decisions will constantly change. They will not be static. They are dynamic. Inference of algorithms. Often there is a whole chain of activities to collect and process the data from various types of sources, and different kinds of algorithms are used. So see, for it is not that for all the applications, same kind of algorithms are used. Different applications are run on different algorithms. So the explainability part of the algorithms will be different from different applications. So it is kind of complex to understand the, where the algorithm went wrong for each application. It is not the same. And then context dependency. Algorithms can be explained at general level as outcomes may be different per individual. So in most cases, no algorithms will be explained at generic level, but not at individual level, not at client level per se. And then the next important challenge is weak nature of the problems are addressed. Okay, the problems may be ambiguous by nature and can be solved in different ways. Algorithms provide one answer that is contestable and changes over time. So as it is as discussed earlier, the algorithm or the solutions changes according to the data. So the problems that are being addressed, the data related to that problem will not be constant over a period of time. The types of the data will be changing over a period of time, right? So does the algorithms. So the explainability will not be constant. It will keep on changing according to the data that is being used. Casualty is not used for making decisions. The casualty is explained between inputs and outputs. This does not mean that the algorithm uses casualty to arrive at the decision. Furthermore, the explanation of casualty might change over time. Again, right? The casualty or the mapping of the inputs to the outputs may change periodically because the data is not constant. The nature and the weightage of a particular data may change over a period of time. It will not be constant. So all these challenges have to be addressed for realization of true benefit of XAI. And one more challenge is not mentioned here. See, for a traditional machine learning algorithm, how do you evaluate its performance? There are some metrics, right? If you take classification, there are some metrics like accuracy, precision, recall, ROC, all those things. If you take regression, again, there are some metrics. Root mean square error, right? R square, and then mean absolute error, root mean square error, right? Yeah, all these kinds of parameters are there. Sorry, metrics are there. But coming to XAI, you don't have any metrics. There are no metrics available to evaluate the performance of explainable TI. That is also one of the major challenges to measure how good the explanations are. Well, this is what I wanted to cover in today's class. Again, I thank Dr. Divya for giving me the opportunity to interact with you guys. And I thank you all for your patient listening. Now, if you have any questions, you are most welcome to ask any questions.
So that was really a very informative session. So,
Okay,
but at anyways, like if participants, if you have any queries, you can please feel free to ask now.
If we don't have time now, you can even contact me through mail also. I'm always available. You can drop me
Yeah.
a mail for any kind of interaction. I'm available through mail.
Okay. So like while I share